All right, good morning. If you're getting this, you are one of the people that wanted to do a retest. Before we do it, I want to practice a little bit more because I don't want to, well, we're not going to do this twice. That's the bad news. So, some things we got to figure out. There's no way you're going to make it without knowing how to do a gradient. So, I opened up, this is the same test you guys did, only it's in Cami. So, gradients, which is a hill slope. When you look at one of these maps, this is showing us a hill on the surface of the earth with a little valley here for the river. They want us to do a gradient from A to B. I know it's down there, but it's okay. I'm just going to do my work up here. All right. This is like when I showed the image of my son hurting his face, the idea would be that you would ask, well, how steep was that road? Why was I letting him ride on a road that steep? We can mathematically answer how steep roads are. And it's an essential earth science skill. It's going to show up. So basically, let's pretend that this hill we're at right here with B up at the top and A down at the bottom. So how steep is the hill? It's a ratio, it's a division problem, and it's exactly like slope in math class. It's rise over run, or you can say change in y over change in x, or uphill divided by distance, change in value divided by distance. So from B, from this elevation, which is at 100, down to A at this elevation, which is at 50. How much did it go down by? It went from 100 to 50, so it went down by 50 meters. Now, 50 meters could be a lot or a little. If it's 50 meters over a really short distance, like over 1 kilometer, maybe that's a steep hill. If it's over like 20 kilometers, that's going to be barely noticeable. So that's the other part we got to do. Normally, you take like a little piece of paper and you make a key, but since we are playing with the computers this year, I made it easy for you with this thing. So that's over a distance of 4 miles. That's mathematically, that's it. That's how steep this hill is, that it's 50 meters. The slope was 50 meters per 4 kilometers. And then you hit some calculator buttons to get your answer. 50 divided by 4 is 12.5. So that's a slope of 12.5. And if you did your labels properly, they're sitting right there for you, meters per kilometer. All right, got to happen. You're going to have to show me on a practice, and then we'll do the actual quiz. All right, so that's the gradient. One possible elevation for x. A lot of people mess this up. If each one of these lines is 10, which it tells us right here, and also you could have like figured that out. I mean, there's 50, there's 100, so you do 50, 60, 70, 80, 90, 100. Yep, they're tons. This would have to be higher than 100, but even if it might not even happen, or maybe it's off the map, the next line up would have to be 110. So x has to be somewhere in between 100 and 110. And any answer within those was fine. 101 up to 109. All of those were good. The thing with the V's is still having some problems. So the contour line will make a V, and this happens because of erosion eating away the land and taking it downriver. So that elevation creeps its way upriver. So you get these like V marks that point upstream. Water itself flows downstream. So people will say it comes out of the open end of the V's, or the V's point upstream. All right, so again, I'd be ready for one of those. How can you tell where the steeper hill is? It's where lines are close together. The closer together the lines, like probably right through here, means you're changing. It's basically doing this gradient calculation only like quick visually. Hey, 3 lines real close together means you're changing by 10, 20 fold meters in that short distance. Whereas like up here, you could draw a circle the same size and you're changing by less than 10. The lines are far apart. It's less steep. Which profile is correct for C to D? I said that C is here on 90, and we went down, down, down to a river. The river's going to be the low points. And then if you see these lines coming like up and back around, like this, it was this one here, saying that it went down and back up. Wasn't perfect, but it was certainly not a hill. Certainly not just like a one steady downhill. It goes down and back up, and this one just didn't go down by enough. This one could have been better. But that's that. All right. This will be here exactly like this, only with different numbers. Depending on what class you're in, you probably took this with different numbers because it changes around throughout the day. It's basic algebra. It's tough. I mean, it's tough for me to say like just do algebra. Like I might not be a great algebra teacher, but whatever you got, that equation is going to be given to you. Just plug in what you got, what you don't have. The first one is the easiest because you just have. Let's switch to text. 543.1 over 488.4. That's the mass, that's the volume, that equals the density. So plug this into a calculator. I'm not going to do it now. What if you have to do another one? Density is 2.83. And that's going to be, what are those equations? I wonder how that is. That's going to be equal to, still mass, always equal to mass over volume. So 65.4 over what you don't know. We don't know the volume over V over X, whatever, it doesn't matter. And then you can put this over 1 and cross multiply. Again, I've done a lot of them. I think if this is like a struggle, then let's meet and talk rather than me making everybody sit through it. But solve for X. 2.83 X equals 65.4 divided by 2.83, and you're there. The last one is going to be, it's the same concept. Again, always back to this equation. Density of 1.54 equals mass over volume. I don't have a mass. S, X, or make it an M, doesn't really matter. Over 543.2. And you got it. Solve for X. And if putting that over 1 helps, to do it. If you know how to do it without that, then that's fine too. That's going to be X equals the product of those two if you multiply them. All right. It's not like memorization. It's just chucking numbers into this and solving for X. If your algebra is way behind, then that might be the problem. Then we can work on that. We can practice that. You can check your algebra teacher for help. But that'll be it. So on this quiz, I'd expect the same thing. We're going to do 2 things. I don't want to give a quiz that you make the same exact mistakes on. So I'm going to throw a worksheet at you, a little bit informal. It'll kind of look like this, or I'll ask a couple of things. If it looks like we have worked out the problems, then I'll say go ahead and do the quiz. Maybe Thursday, Friday. I know you want to get it in before 5 weekers. Yeah, sound good? And then you'll do that quiz. I'll get it in there as long as we do it by Friday. I know that thing ends Friday, but I don't have to put in my numbers till Monday or Tuesday. So we'll get it in there over the weekend. All right, guys. Thanks for watching. Good luck.